Sigma Law PBSA. Party-based sentiment analysis, a legal opinion text. The research team of Sigma Law PBSA. First of all, let's get into the research problem. This is Lloyd George. He receives new cases from clients daily. When a lawyer receives a new case, he has to manually go through all related previous cases to obtain some information like arguments, counter-arguments, facts and evidence, advantages and disadvantages arguments, and contradictory statements. With the increasing number of legal cases, professionals typically endure heavy workloads on a daily basis and they may be overwhelmed. Therefore, lawyers may be unable to deliver a quality result. When analyzing the court cases, identifying advantageous facts relevant to legal parties is one of the critical and time-consuming tasks. By automating this task, legal officers will be able to reduce their workload significantly. We introduce a solution to predict sentiment value of sentences in legal documents in relation to its legal parties. Party-based sentiment annotator automates the time-consuming manual process by predicting the polarity levels, which are positive, negative, or neutral, of sentences in a court case with respect to each legal party. This research is mainly based on the concept of aspect-based sentiment analysis. Aspect-based sentiment analysis is a text analysis technique that separates a text into aspects and then allocates each aspect to a sentiment level like positive, negative, or neutral. Consider this example. Food and prices are taken as the aspects, and you can clearly see that the sentiment takes the positive sentiment with respect to the food aspect and negative sentiment for the prices aspect. The architecture of Sigma Law PBSA. In the Sigma Law PBSA model architecture, there are 6 layers. First, the context and aspect sequences are input separately to the word embedding layer. The word embeddings or the output of the word embedding layer are then fed into the sentence state LSTM layer. This layer outputs corresponding hidden states for context and aspect sequence separately. Then, these hidden states and the generated dependency graphs are passed into the position-aware attention layer. The generated output of the position-aware attention layer is input into the GZN or graph convolution network. Basically, this GZN layer captures the sentiment interdependencies among the target aspects within a sentence. GZN sends its output to the output layer or the classifier that gives the sentiment classes of each aspect. Now, let's move on to the small demonstration of Sigma Law PBSA. Here, the user can enter a sentence taken from a court case and corresponding petitioner and defendant members to the input fields of sentence, petitioner members, and defendant members respectively. Now we'll see some examples.